A few weeks ago, I posted a review on the new Optolong L-Synergy filter, which is Optolong's new dual narrowband filter aimed at capturing sulfur and oxygen. It's designed to be used together with the already very popular L-Extreme filter, which collects hydrogen and oxygen. As part of the review, I tested the filters together as recommended, and then I showed you and not just the individual results, but also explained the high-level process I went through to combine them. Finally, I showed the true Hubble Palette image I was able to create with these two filters. I received quite a few requests to explain in more detail how I put those filter images together, and that's exactly what we're gonna do today. Of course, you can also follow this tutorial if you're working with dual band images from any other brand. Let's get right into it. My name is Lutza and you're watching the Space Koala. So why are we even trying to do all of this? The reason is simple. We want to create proper Hubble Palette images. As explained in the L-Synergy review, the Hubble Palette maps sulfur to red, hydrogen to green, and oxygen to blue. It's not just an aesthetic choice, it actually highlights the chemical composition and structure of a nebula. The challenge is that with a one-shot color camera, hydrogen and sulfur both fall into the red channel, which makes them impossible to separate. That is exactly why the L-Synergy filter is so valuable. It isolates sulfur, and when you combine it with the L-Extreme, which captures hydrogen and oxygen, you can finally have three distinct channels for a true Hubble palette. This is far superior to using a faux Hubble palette where you just reassign colors in software without really having the data. Basically, face value processing that doesn't give you the real thing. As we are working with two filters, one of them collects sulfur and oxygen and the other one collects hydrogen and oxygen, it's clear that we have to find a way to combine all of their respective channels in order to end up with three new channels: sulfur, hydrogen, and oxygen. The way we do this is fairly straightforward. From the L-Extreme, we extract the red channel, which gives us hydrogen. From the L-Synergy, we extract the red channel, which gives us sulfur. And then for oxygen, we take all of the remaining data, meaning the green and the blue channels from both the L-Synergy and the L-Extreme, and combine those together to form our oxygen channel. At the end of this process, we have three separate images: sulfur, hydrogen, and oxygen. We then assign them back into a color image with sulfur going into the red channel, hydrogen going into the green channel, and oxygen going into the blue channel. When we combine these, we end up with a beautiful and well-balanced Hubble Palette image. So now let's see how we can actually do all of this in PixInsight. We start out by having all of our images ready. In my case, I organize them into folders. I have one folder for the L-Synergy and then one folder for the L-Extreme. Of course, each of them has their respective flat frames. This is very important. You're always going to need separate flat frames for each filter. For the processing, we're just going to use WBPP in PixInsight. So we add all of our light frames and our flat frames. We also need to make sure that we have some sort of calibration frames included. In my case, I'm just using biases. With this camera, I don't tend to use darks a lot. In the Lights tab, we make sure that image registration is turned on. Image integration is, of course, turned on as well. I also like to have auto crop on. You don't have to do that, but it's just my preference. Everything else in this tab you can leave according to your own workflow or preferences. In the Calibration tab, you can see that there are some issues right now. In this case, I'm going to turn off cosmetic correction because I'm not using any darks, and without darks, I can't do cosmetic correction. Everything else I just leave as default. So in total, across both filters, we have 11 hours and 40 minutes of integration time. At this point, I just select our target directory and run the process. Once the process has finished running, we end up with a number of master frames. I'm going to open the two auto-cropped versions of both master frames that we got with the two filters. So once we have our master frames open, the one with the L-Synergy and the one with the L-Extreme, we can have a look at them. As we already discussed last time, they look vastly different. The L-Extreme is much more on the red side, whereas the L-Synergy is looking much more green from the oxygen. I will rename them. HOO for the L-Extreme and SOO for the L-Synergy filter. This is just to remind me of which channels I want to use from each of the images. The only thing you're going to do on these images at this stage, if you want to, is deconvolution. That is something that should correspond entirely to the whole optical system you had. In my case, I used 2 separate telescopes for the 2 images, so of course I cannot process them at the same time for deconvolution. I'm going to open up Blur Exterminator, and I will just use this on this small section right here and see if I can do any sharpening. Obviously it works, but it is very strong and unnatural for my liking, so I'll turn it down a notch and a little bit more. Now it looks a bit more natural, so I'm going to use this setting in Blur Exterminator on this image, and then I've also decided to use the same thing on the other image as well. Of course, the PSFs will be automatically calculated for the other image. After we're done with the deconvolution, we're basically finished with these images. From here on, we're not going to be working on them as complete pictures. We're just going to examine the stars for a second. I remember last time I processed this, I decided not to use the stars from the overall combination, and instead I kept only the ones that came from the HOO image. But essentially, this is the point where you would make that decision. So what I'll do is simply duplicate this image. I'll rename it HOO for stars, so I remember why I have this picture there, and then I'll just set it aside for now. It's time to get our channels in order. I'm going to use the channel extraction process in PixInsight. I'll leave everything on default and simply execute it on the L-Extreme image, which will give me 3 separate images for the 3 channels. And then I'll do the same on the L-Synergy image, which will also give me 3 channels from that picture. Remember, HOO, so the L-Extreme, has hydrogen in the red channel. So what we have in the red channel there is our hydrogen signal. At this point, I'll just rename it H, and we're done with the hydrogen. Next, the same thing. We remember that the L-Synergy has sulfur in the red channel, so we'll do the exact same thing. Take the red channel of the L-Synergy, rename it S for sulfur, and set it aside. What we're left with are the 2 green and 2 blue channels from the 2 filters. And all of these actually contain only the oxygen signal. So in order to get the best possible signal-to-noise ratio, I'm gonna be saving all of these separately. I'll create a new folder called Integrated, and I'll simply save these 4 images there. You can just click Save As, or you can press Command-Shift-S on the Mac. I don't know what it is on Windows. I suppose it would be Control-Shift-S. But in any case, you just save the 4 images separately. Once we're done with that, I'm going to open up the process image integration. I'll load the 4 images that we just saved in the new folder separately, all of them together. Now, in terms of the parameters, you can do what you want, but I usually leave most things at their default settings. I will set a rejection algorithm though. Since we only have 4 images, we cannot use anything nice like linear fit clipping. So I'm gonna have to use Winsorized Sigma clipping. Everything else here just stays on default. And then I'll click on Execute Global, which will generate the integrated image for me. So this is our integration. It contains all of the oxygen signal. So I will just rename it O. And at this point, we have our 3 separate channels that we're going to use to set up our Hubble Palette or SHO image. We can actually already do that right now. I'm gonna be using the ChannelCombination tool. We'll fill in the 3 slots with the names of our pictures, so S, H, and O. And also you can just open up the little images and drag and drop their labels into the slots. And then we just click the circle to execute globally, and right away we have our SHO image. What we see is that, I'll just rename it right away. If I auto stretch this, what we see is the whole thing is green. If I turn off the linking and the screen transfer function, that should give us a better idea of what the picture really looks like at this stage. At this point, you can see that the stars are really not nice, so we can go ahead and get rid of them right away. I'm gonna do that immediately with Star Exterminator. We knew ahead of time they wouldn't be super nice. That's always the case with the narrowband images. Once the stars are gone, we're left with a pure SHO image. Now, while the colors look quite nice, remember, if you link them together, they don't actually look like this. The whole thing is still green. So what we'll try to do now is rebalance the channel so the final image looks more balanced overall. This is where color calibration comes in. What this step really does is fix the white balance of the image, making sure that the areas that should be neutral, like the background, actually appear neutral, and that the relative strengths of the colors are properly balanced. Without this step, the SHO image would stay overwhelmingly green, which is normal because 90x% of the signal out there is hydrogen. So to do this, we're gonna run a color calibration process. First, I'll open up background neutralization, then I'll define a small preview in a relatively dark area of the image. This will be our background reference. This is because we are super zoomed into this nebula here and we do not have any actual background. And I'll set that small dark preview as my reference and execute the process. So this is what we look like right now. Next, we're gonna open up color calibration. For the white reference, I'll define a nice bright part, essentially most of the nebula. And for the background reference, I'll use the same dark preview we defined earlier. It is also important here to turn off structure detection in the white balance area. After this step, we end up with a very balanced Hubble Palette image that already looks much closer to what we want. So let's take a look at the unstretched image. While we're still technically in the linear stage, since we changed the histogram so much by applying the color calibration, the image now looks almost non-linear. We'll just keep that in mind and move ahead with a general stretch. I'm going to be using a generalized hyperbolic stretch for this. I will place my symmetry point at the left wall of that little mountain of signal, and then start adjusting the stretch factor and the local intensity until I reach a point where the image looks nice. There really isn't a strict rule for this. You just have to watch the screen and go by what you like. At this stage, the image looks pretty good. From here, we can start shaping the image to our liking. At this point, I'm mostly going to be using the Curves Transformation tool. I always check the live preview and start applying curves carefully. I make sure not to lose detail in the dark nebula region between the North America and the Pelican nebulas because that area is super dusty and really dark, but it still has important detail that we want to preserve. So what I'm gonna do is compress the image a little bit. On the luminance curve, I'll bring down the white point slightly. This darkens the whole image, especially the brighter parts, but it compresses the dynamic range in a way that allows me to apply a stronger curve later and achieve more contrast without losing faint detail in the background. At this stage, you can also experiment with the white balance if you like. The blue curve in particular changes the overall mood of the image dramatically. If you push it up, you get into that golden blue bicolor look. And if you pull it down a little bit, you'll see the image shift into a much more greenish tone. For now, I'll just leave that at 0, but it's good to know that you can control the whole vibe of the image quite a lot here by adjusting the color curves. I will, however, increase the saturation a little bit after tweaking it. I'm happy with these settings for a first round of curves. I'll apply them, and I think this gives us a very nice looking image to continue with. So the only thing missing from here is our actual stars. Let's add them back. Remember, we have our separate star image called HOO for stars. Now let's see how we can turn that into a semi-decent star field image. We'll start by opening it up, and the first step is to plate solve the image. Since it already has all the coordinates, this should go fairly easily. Once the plate solution is done, we can open up spectrophotometric color calibration in PixInsight and switch to the narrowband filters mode. Then I'll modify the default filter widths from 3 nanometers to 7 nanometers, which is correct for the L-Extreme filter. And of course, we need to make sure we optimize for stars. This step will make the star colors as realistic as possible. I mean, they'll never be truly realistic with narrowband filters, but this way they'll look better than they would otherwise. And in just a few seconds, we have our star optimized image. These are the stars that we're going to use in the final picture. What we do next is stretch them. I'll remove the SDF and once again open up the generalized hyperbolic stretch tool. This time I'll stretch all the way from the left without moving the symmetry point, and I'll slowly start stretching until I'm happy with how the stars look. I'll zoom into a small area to check. What I want is for the smaller stars to start showing up clearly, while the larger stars don't get blown out. The way to achieve this is by adjusting the local intensity so that the curve is flatter, which prevents the cores of the brightest stars from saturating. Once I'm satisfied with the stretch, remember, this image is only for the stars. We don't really care about what the nebula looks like. With that done, I'll open up Star Exterminator again. This time I'll use a large overlap setting and let it generate our star field. So we have our star field, and now we have to put it back onto the image. I'll copy the name of the star field and see what happens if you add it back using Pixel Math. So yeah, I'm using Pixel Math to add back the stars with the combination operation set to screen. This is generally the right way to add stars back instead of just straight mathematical addition. After adding the stars, I recommend doing your final curves adjustment with the stars already in place, and that way they integrate better into the image. Now, I just remembered the previous image that I posted and showed in the original video, and it looked quite different. So I opened it up, and indeed they are vastly different. Last time the balance was much more green, whereas this time I ended up with a gold and blue palette. This wasn't intentional. I also wasn't trying to recreate the image from last time. It's just how the color calibration worked out with different parameters, and I guess I was in a different mood. I wouldn't say that one is better than the other. This time I probably paid more attention to the dynamic range in the dark nebula regions, which I think looks better, but I also like some of the green tones that came out last time and didn't appear here. So really, they're just two different takes. If you've made it this far in the video, let me know in the comments which one you prefer, the greener, more classic Hubble palette or the golden blue version that we got this time. So this image now is 99% done. Realistically, I would take it into another piece of software for final touch-ups, cropping out any weird edges or making any last small adjustments. At this stage, it's really up to your taste. The image as a Hubble palette photo is ready, and from now on you can push it in any direction you like. I hope you guys found this helpful, and I hope that it lived up to your expectations in terms of tutorial for this type of processing. It's been a long time since I posted a processing video, so let me know if you want to see more of this or if there is something specific you'd like me to cover. I'll try, although of course it depends on what kind of raw data I have available. Thank you very much for watching. If you enjoyed the video and haven't yet subscribed to the channel, please do so. It really helps me out and gives me feedback on the type of content people are enjoying. This weekend is the new moon. I'm expecting clear skies, and there's also a star party, so I'm really looking forward to that. And I also have some more interesting content coming soon. So thank you very much, and until next time, I wish you clear skies.